Next is quality measurement matrix for the under the quality management. So how do you assess the measurements for the product? So here we expect the measurement is in the form of numeric values. Okay, product should be in the form of numeric values. That how many attributes that has been checked. Okay, how many objectives of the components that product is going to have, that you checked. Then how many modules that it is going to be present, how many functionalities that it is going to be there in that. All these things are given with the measures for the software. Okay. Software metrics that it is going to contain the metrics in the form of lines of code of the program. First thing, number of lines you are going to write the program. That based on that, the cost is going to be get calculated. This is a fog index is going to be there. Then and there is a number of person days that index that is getting calculated, means number of hours that person is working. Okay, development team is going to work. So those things are going to get processed, and all these things are going to get quantified, and finally that is going to be given as a metric. There are types of process metrics are there. Here in this there are 3 points. One is time taken for a particular process to be completed. How will we going to calculate this? It is total time devoted to the process. Calendar time you will be going to calculate. Time spent on the process, particular process that you will be going to calculate. Okay. Then how many number of people that are working on that also you will be going to consider. Okay. So time taken to particular process that it has been calculated. Then resource required for this means either in the form of developer, this is percentage. Okay. Then we have cost of hardware and softwares that it is going to be checked. Then here the number of occurrences of a particular event. If any defects are going to be there in the program, if you are going to it is being given by the testing team that these are the defects that you will be going to get it in this particular model when you are going to execute this model. Then next time when the same thing that it is going to happen, okay, again you are going to get the errors. How many number of times that you are getting occurrence of this error, that also should be get calculated. Okay. So if it is not going to get not rectified, then it should be mentioned in such a way that okay, these are the errors that you will be going to get in this system, but it is not getting affected to the entire process. That you have to some way that you have to specify these things. For the measurements, the predictor is going to be there. That is approximate cost, that predictions, that is software process it is going to start. Then control metrics are going to be there, measurements, management, decisions. So these are on the flow. Simultaneously that it is getting repeated loop because the software is always going to change. The process is going to change. Metric is going to be, the control matrix is going to be get changes. At the same time, management decisions are also going to change because of the process. It is nothing but any requirements, new requirements if it is going to occur. Then the cost of that, the product, man time, okay, and all these things are man days time. All these things are going to be checked. Okay, and if everything is going to be correct, the software product is being developed, then it is going to check for the prediction of the thing that it is going to be given. That is, metric is going to be given for the management to take the decision for go ahead for the product. How do you use these measurements basically? So measurements are going to be used by using that particular values are going to be considered. So things in this, assign a value, system quality attributes. Each and every attributes you'll be going to assign some values. You'll be going to use one of the method, that is cyclomatic complexity. So it is nothing but in the program how many number of loops are there. Okay, so that it is going to be checked. Cyclomatic complexity, that it is going to tell you that, okay, how many number of times that it is going to loop. Okay, so that, and in the programs, a whole program, how many number of loops are going to be there, that also it is going to be checked in this. Okay, these are the quality attributes that it is going to be given in that. Then it is identifying the system components as a whole. Subsystems are going to be there. It means one program is going to be there already, that what a component is going to work properly. You have to identify the individual components for their characteristics. Okay, how whether it is working properly or not, that it should be measured. So individual components, if you are going to take, and if it is working properly, then the measure of that matrix is going to be correct. If not, okay, then the problems are going to be there in that. Matrix assumptions. Some matrix are going to be proper, some matrix is not going to be. You have to assume that based on the assumptions that you should accept it. Software property can be measured accurately, means whether it works or not, based on the properties of those which is being given, that can be measured accurately. But the relationship between the what we can measure and what we cannot, okay, that is not specified. Okay, here the conflict is going to be there, because all the requirements out of that has been specified, whether it is going to be met, if not met, then whether it is going to be acceptable, this debate is going to be starts. So with the small modification, if it is going to be accepted, then the matrix is also having some assumptions. Based on that, it is going to get executed. Okay, and validations. On these validations, whether we should go for exhaustive validation or the formulated validations. Okay, that it should be checked with the matrix team, that whether these things are going to be accepted or not. Okay, so based on that, the measurement report will be given. Then quality attributes are going to be checked according to the system that which is being specified. Here it has been said the relationships between the internal and external softwares: maintainability, reliability, reusability, and usability. Now you see that maintainability is connected with, okay, these are external attributes, quality attributes, and these are internal. Maintainability deals with depth of inheritance tree, cyclomatic complexity, program size and lines of code, then length of the user manual. All 4 points that it is being maintainability is going to relates, and that is needed for that. Maintainability, depth of inheritance tree, how many trees are getting connected, inheritance trees are going to be present, inheritance data is going to be present, that it must know it, because when you want to change in one location, it is reflecting in the other location also. So you should know about those points. Then cyclomatic complexity, number of loops that it is going to be get executed, that also it must be known, understood. Then program lines of code. Lines of code is going to be, if it is more or less. So if you are going to make it less, why you made less, those things are going to be used for the relationship between the internal and external softwares. Then length of the user manual, if you are reducing also you must specify, if you are going to increase also you have to specify. When you are going to increase, you are going to increase at the time of new requirements. Okay, reliability, it deals with cyclomatic complexity, program size, and number of error messages. Always the product should be reliable, means if I am going to give some inputs, I should give the proper output. So the programming concept which is there for the cyclomatic complexity, then coding is going to be there, number of errors. So if it is not going to execute for those inputs,